A terrifying supermassive black hole was detected by the James Webb telescope. Carl Sagan, American astronomer and astrophysicist, said, "Black holes may be apertures to elsewhere. Were we to plunge down a black hole, we would re-emerge, it is conjectured, in a different part of the universe and in another epoch in time. Black holes may be entrances to wonderlands, but are there Alices or white rabbits? What are black holes and where do they lead?" A group of researchers is hoping that our metaphorical stars are aligned, the weather is perfect, the technology is functional, and everything is going as planned, because we can now see and study a supermassive black hole at the heart of our galaxy that is opening up a new frontier in space research. Together, NASA's James Webb Telescope and the Event Horizon Telescope have produced astounding discoveries about the supermassive black hole in the center of our Milky Way galaxy. What does this mean? A gigantic spinning swirl of hot plasma that radiates infrared light marks the supermassive black hole at the heart of our Milky Way galaxy. This multi-wavelength composite image, which was released in 2009, contains near-infrared light collected by NASA's Hubble telescope and was, at the time, the best infrared image of the galactic center ever made. Dynamic flashing flares in the region immediately around the black hole, known as Sagittarius-A star, have made it difficult for the Event Horizon Telescope, or EHT, cooperation to get a closer, more accurate image. Since black holes don't emit light, they are invisible to telescopes, but the EHT team hopes to capture the black hole itself in a high-quality image of the hot, burning gas and dust that surrounds it. Launched by NASA in December 2021, the James Webb Observatory will have 15 times Hubble's resolution and the capacity to detect a lot more infrared radiation. The yellow pictures seen by Hubble's near-infrared instrument may include hundreds of thousands of stars, stellar nurseries, and hot plasma. Infrared observations using NASA's Spitzer Satellite Observatory uncovers even more red stars and gas clouds. Blue and violet light were seen by NASA's Chandra Observatory, which indicated areas where gas had been heated to millions of degrees by star explosions and black hole outflows. Astronomers say that a new partner will shortly join the Event Horizon Telescope (EHT) collaboration. NASA's James Webb Space Telescope will take part in the project. During Webb's first set of observations, researchers want to use its infrared imaging capabilities to solve some of the recurring problems with Sagittarius-A stars. The Event Horizon Telescope saw the region directly around the supermassive black hole in the galaxy M87 for the first time ever in 2017. Even though Sagittarius-A star is just a few light years from the black hole in M87, its brightness changes hourly, making observations challenging. The study of solar flares, black holes, plasma, and particles may be significantly affected by our understanding of the start, peak, and decline of the Sagittarius-A star. Sarah Markov, a member of the James Webb Sagittarius-A star team and vice chair of the Event Horizon Telescope's Scientific Council, said, "Black holes are just incredible. Black holes are the most severe circumstances in our universe and the places where we can test our most fundamental theories, such as general relativity. Thus, researchers from all over the world spend a lot of time and money studying them." The Milky Way galaxy's supermassive black holes may be seen spinning with hot plasma in near-infrared light from NASA's Hubble Space Telescope. The most tightly packed region of matter that science has yet to find is a black hole, as predicted by Albert Einstein as part of his general theory of relativity. Any light emitted by material that comes too close to a black hole's gravitational field gets drawn into the black hole's warped universe. Black holes seem to be so dark, but why? Telescopes can only detect light coming from the black hole's surroundings, not from inside it. The name of the EHT collaboration is derived from the phrase Event Horizon, which describes the light's innermost edge. A black hole contains one of the universe's strongest gravitational forces, One has to go faster than the speed of light in order to escape from a black hole. The event horizon is this region. Radiation and matter cannot elude each other. Since light cannot leave a black hole, it is completely dark inside. Despite their name, black holes are not voids. In actuality, black holes are small pockets of densely packed matter. Black holes may be found everywhere in space and come in different sizes. We may learn a lot about the origin of black holes from their size. While the origin of certain black holes is understood, the cause of other black holes is yet unknown. Stellar mass, intermediate mass, and supermassive black holes are the three primary categories of black holes, which are distinguished by their sizes. Stellar mass black holes, which have masses less than around 100 times that of our Sun, are common across the Milky Way galaxy. High-mass stars might eventually approach the end of their lives. Hydrogen conducts nuclear fusion at the star's core, creating helium and other elements in the process. The star's central regions emit energy, which creates the pressure necessary to keep the star from collapsing under its own weight. Hair-like wisps of gas are sucked in by the black hole at the top and bottom of the swirl of the burning dust and gas encircling the black hole. This picture shows the stellar mass black hole, IGR J1709-3624, which is part of a binary system. The immense gravitational pull of the black hole is pulling a companion star away from it. This heated gas ring that forms around the black hole blows the wind away. The full image and explanation are provided by NASA. Depending on how much energy is left in the star's core at the time of its death, a very high-mass star that has run out of fuel can either collapse or explode. If the mass of the star is more than 25 times that of the Sun, a stellar mass might form. Black holes of intermediate masses are 100 to 100 million times more massive than the Sun. Prior to this discovery, intermediate mass black holes had only existed in theory. The Chandra X-ray Observatory of NASA has identified a large number of potential intermediate mass black hole candidates using the X-rays produced by the black holes around the gas. Dark spheres, the National Science Foundation-funded LIGO telescope, discovered an intermediate-sized black hole with a mass of 142 solar masses that was created when two objects with masses of 65 and 85 times that of the Sun merged. The mass was transformed to energy, and around 9 solar masses of mass were emitted outward as gravitational waves. Supermassive black holes have between 1 million and 1 billion times more mass than stellar black holes. One theory for how black holes might merge to become supermassive black holes is as follows. This graph displays very dense celestial objects, ranging in size from white dwarfs to black holes, along with a detailed image and written description of each one. A brilliant white cluster of galaxies is encircled by swirls of stellar and stardust. The Milky Way galaxy's center may be seen in this image, along with a close-up view of the Sagittarius A stars. This composite image was made using infrared data from the Hubble Space Telescope with red and yellow X-ray data from the NASA's Chandra X-ray Observatory. The inset shows X-ray pictures of the Sagittarius A star across a half-light-year wide region. Black holes captivate everyone, even seasoned astronomers and little children. Scientists may learn more about the evolution of our galaxy and black holes, in particular by understanding the Sagittarius A star. By examining the physics of black hole creation and growth, as well as their surroundings, astronomers may get insight into galaxy formation. We are closest to the supermassive Sagittarius A star, despite its distance of 26,000 light-years, or 152 trillion miles. When galactic material crosses the event horizon, adding to the black hole's mass, our galaxy is affected by its growth and physical processes. Investigating black holes helps us understand the dynamics of space and time. In contrast to the flow of time at a distance from a black hole, time slows down as one gets closer to one. According to Einstein's general relativity theory, time will slow down as it approaches a large object. Although it is currently impossible for us to travel to far regions of the cosmos, we can now get a sneak peek into other galaxies with the aid of powerful telescopes like the Hubble and JWST. What do you think about black holes? Are they a portal to another time and place, or simply the most dangerous phenomenon in our universe?